Hi, ladies and gentlemen. This is Mr. Green, and this is another in the series of videos that I'm making for geometry. In this lesson this week, what we're looking at is a concept called mid-segments. And what we're going to do with mid-segments is first of all define what a trapezoid is. Well, a trapezoid is an object, a quadrilateral, that has four sides. Now, they want you to understand that it has what we call legs and bases. Okay? A leg is something that joins two parallel sides, and the parallel sides are called bases. Okay? That's really a distinction that you need to make certain you understand very clearly when you're talking about a trapezoid. A trapezoid has two parallel sides, one set of parallel sides. And if you can pick those parallel sides out, those are going to be called the base sides. The legs are going to be the ones that are not parallel to each other. Okay? It doesn't seem like a difficult concept, but it is important because if we're talking about looking at trapezoids and looking at the mid segment, we need to be able to pick out which ones are the bases and which ones are the legs. Why? Because when we start talking about the mid segment, we're going to be using one pair of these legs and not or one pair of these sides and not the other pairs. Okay? For example, a mid segment is something that joins the midpoint of two legs together. Not bases, legs. Okay? So in this one over here, this third one, we're not joining the parallel sides like these two are. So this one would not be a mid-segment. And this one is not joining the midpoint on the legs. You notice how this is much longer than this over here. So that's not a midpoint over here, and it's not a midpoint over here. So this one is not a mid-segment. Okay? This one in the middle is a mid-segment. Why? Because I'm joining the midpoint of the leg here, this midpoint here, to this midpoint over here with a line. That's what a mid-segment is called. This right here is called the mid-segment of this trapezoid. Why is that mid-segment important? Because there's a formula that I can give you to find the length of that mid-segment. The formula is this one right here. It's telling you that that mid-segment is actually 1/2 of the sum of the two bases. So if this base up here is 1 and this base down here is 3, then this mid-segment here is 3 plus 1 is 4 divided by 2 is 2. It just is a factor of adding the two parallel sides together and dividing by 2. Okay? It becomes a really simple little trick to find the length of a mid-segment. Okay? Now, the only complication is sometimes they throw algebra at us. Like this problem right here, where they've got x plus 5. Well, let's just write these down. X plus 5, that's one base. And the other base on here is 3x plus 1. Oh, I know. We add those together just like they were two bases. Okay? We can add them together. And then divide by 2. Divide the whole thing by 2. And what we will get is the length of the mid-segment, x plus 6. X plus 6. That was a very lousy plus. Okay? Now, I remember algebra. We've got some things that are inside of the parentheses here. We can combine those together, and I'm going to get 4x plus 6. And that whole thing is divided by 2 is equal to x plus 6. Oh, wait a second. If it's 4x plus 6, I know I can break that apart and say 4x divided by 2 plus 6 divided by 2 equals x divided by 2, or x plus 6, sorry. Well, 4x divided by 2 is 2x. 6 divided by 2 is 3. And that's equal to x plus 6. I can subtract the x from both sides, and I'll get an x plus 3 is equal to 6. And I can subtract the 3 from both sides, and I'll get that x is equal to 3. So I've actually found what x is. X is 3. I can come back up here and put that value in. 3 plus 5 is 8. 3 plus 6 is 9. 3 times 3 is 9 plus 1 is 10. So if I add 10 and 18 and divide by 2, I get 9. That works. I think we found the length of the midsegments and the length of the two bases there. That's how this works. And we're just using algebra and this midsegment formula that we were given. That seems pretty straightforward. Now, what does that mean? Well, a midsegment of a trapezoid is very similar to the midsegment of a triangle. Why? Well, a triangle is nothing more. If you divide it in half here, you get a trapezoid, don't you? And that was kind of a loose statement. Let's make that a little clearer. If you think about a trapezoid with a top base of 0 length, then what I've got is a trapezoid sitting here of ABC, or ABBC, and that top base has got a length of 0. Then this bottom base down here, AC, is going to be the bottom base. And if you look at PQ, PQ is actually going to be the same length as AR and RC. Oh, that's how that works, right? Because what we've got is midsegments of triangles. When I divide a side in half and connect those two midpoints, what I'm going to get is 1/2 of the third side. That's what this is trying to tell me. Oh, so what we're looking at is a midsegment of a triangle. Here, PQ is actually going to be the same length as this side right here, AR, or this one over here. Okay, color so that we can see this a little better. Let me gain colors. Here. There. All those things in yellow are all the same length. Cool. That makes sense. Okay. So what about the other sides, Mr. Green? Yeah, that's true. If I take this side of the triangle and this midsegment, they're the same length. And so is this one. Okay. What about that third one? Yep. This one and this one are the same length, and so is this one. And so what we're looking at is this, and this are all the same length. This, and this one are all the same length. And then this side and these down here are all going to be the same length. That's the way the midsegment formula works for us in a triangle. Because what we've got is we can actually divide that triangle up and see where these points are and know the distances that we're talking about. Okay? It will help us in the future. Okay. So, what we've got here is a little square. And they're going to have me use this square here. I'm going to show you. If I put the square right here on PQ, well, it's not quite the same length as PQ, is it? So I'm going to expand it out till it's the same length as PQ. Now, if I take this and bring it down here and compare it to AR, it's the same length. If I compare it over here, it's the same length. I'm using something to compare them together, and they're always the same length. Okay? So just like we did with the parallel lines and transversal, the length of a midsegment is equal to 1/2 the length of its corresponding base. The midsegment is parallel to the corresponding base. What we're telling you here is if these lengths are the same, then these two lines, PQ and AC, are parallel to each other. So, which is exactly backwards from what what we were saying about the mid segments. We were saying if they're parallel to each other, then they're going to be it's going to be 1/2 the length of the base. So this base here would be this mid segment would be 1/2 the length of the base. So that is another example of a condition and its converse being true. What we're talking about here is a mid segment. Okay? So let me give you a little problem. Let's see if it makes it a little clearer for you. Okay? So RT, that's this length right here, is 7. ST, that's this one over here, that one's 6. And RS is 5. They gave me these measurements in here. And they want to know the perimeter of the big triangle. Well, if RS is 5, that means that DT is 5. And it also means that TE is 5. And let's see here. What would ES be equal to? ES is going to be equal to that 7. And so is SF. And then RF is going to be equal to 6. And DR is going to be equal to 6. So we can actually find the sides of those triangles. We've got one side that's 10, one side that's 14, and one side that's 12. And we add those three numbers up to find the perimeter, and we get 36. So we found the perimeter of that triangle just by knowing the dimensions on the smaller triangle in the mid segment. That's the type of problems you'll be looking at. Okay? Okay, what we're doing here is we're making conjectures about objects and using a variety of approaches such as axiomic, and that's what we've been doing in this one is axiomic, which are axioms and theorems and things like that. Big word, doesn't mean a lot, okay? And then we're using geometric patterns to develop algebraic expressions representing geometric properties and testing conjectures about the properties and attributes of polygons and their component parts. That's what we've been doing in here. That's what we've been trying to make certain you understand. Okay? So, you have any problems with this one? Make certain you talk to me. Send me a K-mail. Send me an instant message. Just make certain you include the fact that you're in geometry, what section number you're in, because it helps me find your records a little bit quicker. And I'll look forward to seeing you next class. Thank you. Bye.